Hello everyone, I hope you guys are well. Welcome to another short video on C and data structures. Actually, today we're going to be studying trees, more exactly binary trees. We're not going to get into search trees, that's going to be next time. But yeah, so let's see what trees are and jump directly into the topic. Basically, a tree is a data structure and it kind of looks like this. You can ignore the contents because this basically represents a search tree, and this is what we're going to do next time. But yeah, a tree is a data structure in which each node, and these are called nodes, has, in the case of a binary tree, 2 children at most. We can have ternary or B trees, which can have n amount of children. But today we're going to be studying binary trees, and each node can have a maximum of 2 children. You can see that, for example, node number 6 has just 1 children, and that's 13. All these nodes at the bottom, they're called leaves, and a node is a leaf if it has no children. So regardless of where exactly you'll find it, if a node has no children, it will be considered a leaf. So for example, if 7 wouldn't have had this left child 14, then 7 would have been a leaf, even though you can clearly see that it's not really at the bottommost level. Okay, so how do we write trees in C? Well, it's fairly similar to lists. We're going to be needing a structure. So let's just name it type_extra struct node, and let's not put numbers inside. We're going to be doing that next time. This time we're going to be putting chars, and that's going to be an ID, and we're going to be needing 2 children, right? And that's left and right. Okay, and that's about it. And let's give it a name, node. There we go. Okay. Now I'm going to need a function to create this this tree, and I'm going to create it by basically just continuously inputting characters from the keyboard. So for example, if I input this string A, B, D, G, C, E, F, H, and 2 stars, the output tree, and this will be inputted separately. The output tree is gonna look like this. Un momento. Yeah, it's basically gonna look like this. Okay. So let's copy this for a bit and look at what is going on. All right, so I have, let's zoom in. Okay, I have A and B and D. So basically the left side is always covered first. So in case I wouldn't have had this this star here, which represents a null, then the G would have been on the left side of D. So yeah, we read A, we read B, and then we read D, and that's all put on the left side. And then we read the star, which is a null. So here we have no node. And then we come back, and then we read the G, which is followed by 2 stars. So that means G has no children, so it's a leaf. And then we go back, and because D is already filled with a null on the left and G on the right, we go back up, and the next is B's right child, which is a null. So we are here, and go up again. And now we are on the right side of A, starting from C. And if the next node is E, then that means it's on the left side. And E is followed by 2 nulls, so that makes it a leaf. And then we go back and then fill up F. F's left children is a null, and then go right, which is H, followed by 2 nulls, and we're done. That basically, by putting that here, we signal that our tree is done, because all other nodes have filled up with children. Okay, so let's see how we write everything in code. We're not going to be needing this yet. Okay, so I'm going to create a function root equals to get, or rather create binary tree. And let's create this function below. Yeah, that's fine. Okay, now I'm gonna be needing a character, and this shouldn't be a pointer. And let's just read it. Scanf and C. Okay. Formatting in case C will equal to a star, and that's the signal for a null. Return null. Okay. So again, when I reach node, for example, D's left child is a null. And okay, else. Well, actually, we don't need this else, because if it goes on this branch, it will simply return. So let's allocate a node. P equals to node T. Oops. And a malloc. And I know I will need to import you. What? Come on, suggest it for me. God damn it. There we go. Okay, and P of ID will equal to C, which is the char, which I've read. P of left is gonna be equal to create binary tree, and P of right is equal to create binary tree. And here we have and return P. We have a recursive function. So basically I do the same thing for the left subtree and then for the right subtree. And this is why I'm always reading left. First, I'm always going to the left. I can switch those around. That's not a problem. We'll just keep it like this for now, for the sake of simplicity. Let's just see if this works properly. I'm not going to be seeing anything at the end, or maybe just printf root ID, and here I'm going to put a, yeah, oops. Okay. Now let's run it. And it's expecting me to input some characters, and I'm going for just a few of them. Oh no. What is wrong? Something is wrong. Should end. Okay, so what did we do? What did we miss? What did we do wrong? All right, so finally I found out what was going on here, and it's basically because of how CLion treats the terminal and how you end up reading stuff from the terminal. Now I have a small workaround, and I'm gonna be doing this. I'm just gonna allocate a string of one character. There we go. And instead of this, I'm gonna put string compare, but before that, let's just include string.h. And finally here, string compare C with this, and then we return null. And instead of doing this, we're gonna be putting the first element of the string, and here it equals to 0. Okay, finally, let's run. A, B, star, 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 and yeah, now it works just fine. Okay, so let's see if this thing works properly, and for that we will have to write some function which prints our nodes. Now, there are 3 ways in which you can traverse a tree. The first one is called pre-order, the second one is called in order, and the third one is called pre-order. And we're going to be implementing all 3 of them. So for that, let's just write the function here, preorder of root, and it will take as an argument a level, which starts off from 0. Now let's implement this function, create new function. Yes, this looks fine, but instead of I'm gonna name it level and current root. Okay. And then let's start implementing it. Now, if this current root is different from null, then we can actually do stuff. We're going to be using this level just for indentation, just to make things a bit more pretty. So for int I equals to 0, I smaller than level, I plus plus, printf a space. This is everything we're going to be using level for. And then we will use something like this, printf c and current root of id. Okay, and then we call preorder of current root of left with level +1. And we can't use level ++ here because we're going to be using the same level on the right side, and we don't want to increment it here. Okay. Now let's see what this preorder does, and I've already put it in main. So first off, I'm going to be reading my tree, and I'm going to be reading the initial one, which I still have here. And star. There we go. So now this printed the following string: A, B, a space, D, bigger spaces, G, C, E, F, and H. And this is the pre-order traversal. So why this order? Basically, it is the exact same order in which I inputted the elements. And what preorder does is, before going on the left or right side of the node I am currently in, it prints out its value. So I start off from A, which is my tree's root, and then I print it out. I print A, and then go to the left side, and before going forward, we print B, and then we go forward to the left side and we print D, and then we go forward to the left of D, which is a null, and do nothing, because here I have this check if current node is different from null, and if not, I don't really do anything. And then I come back and then go to the right side and print G, go left, nothing, go right, nothing, and so on. So printing is done before any other recursive call is being made. And that's preorder. Okay, so you might intuitively guess what in-order is. So an in-order traversal looks like this. And let's create a new function for it. Here I'm gonna change it to current root, and here I'm gonna change it to level and create. Okay, this is gonna be mostly the same. However, there is one thing that is different. This printing alongside with this is done after going to the left side of the tree. Let's see what this does here. So this goes from A, and it doesn't print it yet because it can go to the left side of A, which is B, and again it doesn't print it, and it goes to the right side of D. You know what? Maybe it will help if I also put this here. Okay, there we go. Okay, I can how can I make this larger? Here and then here, and zoom in. Okay, so now it's even better. you see that this line, this pre-order call, well, this shouldn't be a pre-order call, actually. This should be in order. Oh, in order. Otherwise, it gets really confusing. Okay. And I'm gonna need to do this again. Voila. Okay. So, before printing anything, we go to the left because of this. And go to the left again because we reached D. And again, we go to the left because we can. But then the current node is null. And so we return to D. And currently at this point, we just exited from here. Whoa, this is rather large. So we just exited from here, and our next instruction is this. So we printf the lines, and then we get to print the ID. Now the first ID, which gets printed for an in order traversal, is always the leftmost node. Okay, so that is D. Even though G might be lower, it's not the leftmost node, so that means that it's D is gonna be printed first. And then we go here, we finally go on the right side of things, and we go on the right side of D, and we attempt to go to the left of G, but that's a null. And then we come back, and we come back from here, and then the next node which gets printed is G. And then we attempt to go to the right of G, and it's a null again, and we return from this function as well because we were on the right side of D. And finally, we're done with D and return to B. So we exited here from B, and then we print out some spaces, and then we print B and attempt to go to the right side of B, which is a null, and well, nothing happens. Finally, we exit B and we reach A, and we were on the left side of A. So this is the function from which I exit at this point. The next thing to do is printing out some spaces, and here we print A and go finally to the right side of A, where this whole process repeats itself. Which is the order in which these nodes are printed? It's gonna be D, G, B, A, E, C, F, and H. So let's see if that holds true. I have a pre-order and I need a new line here. And then in order. So it looks a bit ugly, but that doesn't really matter now. The in order traversal is DGBA. Let's copy it from here and put it here. Whoa, that doesn't help. There we go. Now the in order traversal is DGBA, and then we go from E, C, F, A, H, and this is what I said before. So, that was right. Okay, now there's one more traversal which I'm just gonna copy. It's called post order, and you might guess what it does. Instead of printing things before or in between those two recursive calls, we basically print it afterwards. Now looking at this tree, how would that look? I need to traverse both sides, and only after I've done that do I get to print something. So let's copy this here. Now I go to the left, and I go to the left, and I go to the left again, and it's a null. So finally I exit from here, and then I attempt to go to the right, and I do that on G, And on G, I go to the left, there's nothing. I go to the right, there's nothing. And finally, I exit the function. I exit this one with the current root being G. So I print it out. That means that the first output is G. And I finally exit from here as well. And that means I'll print D. But I'm on the left side of B, so I need to go to the right side, but that means nothing gets printed because B has no right child, and then B gets printed. So currently I have G, D, B, and then I go to the right side of A. I don't get to print anything because I'm currently here with the current root A. And the process repeats itself again. The next node to be printed is gonna be E, and then it's gonna be H, F, C, and A. So that means it's G, D, B, E, H, F, C, A. Let's see if that holds true. Okay. Let's copy this. Whoops. And instead of in order, we put post order, print, and finally, I think for the last time, we star. Now, there we go. It's G, D, B, E, H, F, C, and A. So for a post order traversal, the root node is always gonna be printed last. All right, so these are the basics of trees. The basics of binary trees at least, and the 3 ways in which you can traverse it. Yeah, that is it for now. Next time we will be doing binary search trees, and also we will be discussing perfectly balanced trees, because yeah, it's a very important thing in binary search trees, so that they are perfectly balanced, but that's gonna be a topic for next time. You have your assignments in the Git repository. Please make sure to do them. And that's about it for today. Have a wonderful week, and actually have a wonderful weekend and then week, and see you next time. Bye-bye.